Hello, everyone. Welcome to this video where we are going to discuss about transactions and concurrency control. So in this lecture, we are going to understand what is a transaction, what are the operations involved in a transaction. We're going to look at single user and multi-user systems, the difference between the two. Then we are going to explore the need for concurrency, what is concurrency, and the need for concurrency control. So let us start off directly by looking at what is a transaction. So a transaction in a DBMS is a single logical unit of work that consists of one or more operations, which is performed on the database. So this is the definition. So a transaction, basically what we mean is a single logical unit of work, means that it is considered that a transaction will either execute completely or will not execute at all. And it consists of multiple operations. Now, what are these operations? There are two basic operations in a transaction, which are of importance to us. And these operations are your read operation and your write operation. So these read and write operations can be on a data item which is stored in the database, which is named X. So we have given the name X. Now X can be one record that is stored in the database. It can be one block which is stored in the database. It can even be one attribute, one value of one attribute X. So read X, it reads the value of the data item into a program variable. And write X writes the value of the program variable into the database item named X. So it is basically read and write from the database to the program and from the program to the database. So this during the read item operations, these are the things which can happen. First of all, the item that we want to read X is stored in the database. So the first step is to find the address of the disk block where that data item X is stored. Next, because the program cannot directly access the data on the in the disk block, that is in the hard disk, so that block, that block where the data item X is present is copied into a buffer in main memory. Because your program can only access the data which is there in main memory. It cannot access the disk block. So it has to be transferred from the disk block to the main memory. And then from the main memory, from the buffer area in the main memory, it is then transferred to the variable in your program, which is called X. So this is how the read operation occurs. The write operation is just the opposite of this. First, your data is now in your variable. The data is in a variable called X in your program. From here, you copy. First of all, first step is same. Copy the address of the disk block that contains item X. So first find where in the disk, where is the item X stored. Copy that block to buffer in main memory. Then copy the item X from the program variable to the correct location in the buffer. So this X is first in your program. From program, it will be taken to the buffer. From the buffer, it will be copied to the disk. It will be copied to the disk. So last step is once from the program, it comes to the buffer. From the buffer, it will be transferred to the disk. So this is what happens in a read and write. Now, here we can see two examples of two transactions. So here, T1 is a transaction. It has got these operations. Read item X. So when we say read item X, it follows the steps that we have discussed earlier. Then it subtracts a value N from X. And then the updated value of X, it writes it back to the disk. And the next is read item Y. So Y is another item. X and Y are distinct from each other. And what we have done is we have updated Y, we have increased Y by the quantity N. And then the value of this updated value of y is written back to the disk. So you can see what is of importance to us is these operations, read item and write item. So in a transaction, you can see this transaction T1 consists of these operations and it is considered as a single logical unit. So either all the instructions will be executed or none of the instructions will be executed. Similarly, we can see another transaction T2, which consists of a read item X, then updation of X by a quantity M, and then writing the item X back to the disk. Now that we understand transactions, let us look at single user and multi-user systems. So most of the time, we use systems unknowingly. We do not know, we are all using at some point of time in our life, we have used a multi-user system. So in multi-user system, many users can access the system concurrently. So there can be a lot of users who are using the system concurrently, means at the same time. So for example, your online banking system, your airline reservation system, like say Make My Trip or Yatra, your delivery apps like your Swiggy and Zomato, all of these has got many users who are accessing the data at the same time. So these are your multi-user systems. And single-user systems also are there where it is a very small system where only one user is using the system. So at any point of time, only one user is using a system. So maybe let's think of the system, some inventory system in a small shop. Only the owner is using and updating the database. So that is a single user system. Now, when multiple users are accessing the system concurrently at the same time, then there can be a number of issues that can occur. And that is when your concurrency comes into the picture. So concurrency basically means at the same time, concurrently. So concurrent execution of transactions. Now these transactions can be executed in an interleaved manner. That means you have, let's say you have one CPU. This is the CPU time. So from this time to this time, let's say user 1 or transaction 1 is executing. From this time to this time, let's say user 2 is using. Then again from here to here, let's assume that user 3 is using. So in this way, you see, again, you may happen that user 2 is using again. So the CPU time is divided across the different users and their transactions. So user U1 may be performing transaction T1, U2 may be performing transaction T2, T3, and then here would be T2. So this is here known as your interleaving process. So single CPU, one process is executing at a time, and this time, CPU time, is allocated to different users. And in case of parallel processing, you have multiple CPUs. So each multiple process will execute concurrently on multiple CPUs. So here maybe I have user U1 is using, here user U2 is using, here user U3 is using, and so on. So, but all of them are executing at the same time. So we have, this is your interleaved processing and parallel processing. Now, why do we say that when concurrently users in a multi-user system which allows concurrent processing, what is the problem? What is the issue? So there are a number of issues and we'll look at them one by one. The first problem is called the lost update problem. Let's look at this here. What is the lost update problem? If you look at this diagram, which has been taken from the El-Masri Nawate book. So here you can see there are two transactions, T1 and T2. Okay, and you can see that from this time to this time, initially, two instructions of T1 is executing. then two instructions of T2 is executing. And then again, T1 is executing two more instructions. Then T2 is executing one instruction. And again, here we have T1 again is executing the remaining two instructions. So we have these instructions being interleaved between transaction T1 and T2. So if you are assuming that it's a single processor system, so the CPU time is shared between transaction T1 and T2. And the way this whole process, all these operations are shown, this is known as a schedule. This is a schedule. Okay. So let us see now what we are doing here. So what is this? What is the issue in these instructions? So the problem that we are going to discuss is the lost update problem. So lost update problem occurs when two transactions that access the same database item have their operations interleaved in a way that makes the value of some database item incorrect. So as you can see in this transaction and in this schedule, first the read item X of T1 executes. So let us assume that X has a value of 100. Okay, so T1 reads in the value 100. Let us assume that N is 5. Okay, so in the program, the value of X becomes 105. Oh, sorry, 95. We are subtracting 5 from it. So in the program, the value is 95. Now you can see that after executing these two statements, before it can be actually updated in the database, let's assume this is the database. N is a program variable, so N will be here. This is your program. So before this value 95 is updated to the database, transaction T2 start executing. And transaction T2 is reading the same data item X. So in the program for transaction T2, the value of X read would be whatever is there in the database. So X would be 100. And let us say M is 10. So X would become 110 in the program of transaction T2. Now you can see next again the transaction T1 gets to execute. So now what it does write item X. So write item X, as I said, from the program, it will be updated to the database. So currently the value of X in transaction T1 is 95, and this will be written to the database. So X in the database would be replaced by 95. Now, if you come to the next operation Y, okay, let's assume Y is 50. So it reads Y here. So 50 is read, and 50 is increased by 5. So Y will become 55. Okay. Oh, sorry. Before this happens, it will go back here now to transaction T2. So here you can see write X. We have write X. So now transaction T2 will write the value of X to the database. So what is the value of X in the program of T2? It was 110. So this value will be written to X. So this 95, which was written by transaction T1, will get lost. The update made by transaction T1 to the data item X will get lost. Only the one which does the write operation last, only that update will remain. So the work done by transaction T1 is lost. So this kind of a problem, this is known as your lost update problem. The update made by transaction T1 is lost. So this is a lost update problem. Let us look at the next one. Next is a temporary update problem. Okay, so now this type of transaction, this type of a problem will occur when one transaction updates a database item and then the transaction fails for some reason. Okay, so you can see here we have transaction T1 read X. Let's say again in the database, X has the value 100. Here it reads the value of X as 100. Then N is 5. So it performs N minus this. So this becomes 95. Then it performs write. So the update has been written back to the database. Now we come to the second transaction, transaction T2. So here also it performs a read. Now what value will it read? The updated value. So it will read X as 95. And if M is 10, so I will have the value of X after updation will become 105. Okay, and then it says write X. So it is written X here 105. Okay, and then now we come to this one. We come to the next item instruction in transaction T1. Okay, so this is reading a different item. So we are not bothered with that. Now the problem will occur if transaction T1 fails. Okay, for some reason, transaction T1 at this point, there is a failure. And if you can recall, I said that in a transaction is a either all the instructions will be executed or none of the instructions will be executed. So if at this point there is a problem, this transaction fails, then we have to undo all of these operations. So all these operations which was done by T1 has to be undone. But the value which was updated by T1, the value of X which was updated by T1, 95, has already been read by another transaction T2. So even if we undo transaction T1, transaction T2 has already read that value, the value which was updated by T1. So that value should have been a temporary update. Okay, so in such a case, the transaction T2 will be reading a wrong value. The value of X before T1 and T2 was 100. So T2 should have read 100 if T1 is undone, or you roll back transaction T1. So the value read by T2 is a wrong value, and this is known as a temporary update problem. So the updated, what is the problem? The updated item is accessed by another transaction before it is changed back to its original value. So when transaction T1 you reverse this or you roll back the transaction, then X should have received the value 100 in the database. But because T2 has already read it, so that is not done anymore. Now the third one, the third problem is your incorrect summary problem. So here we are talking about aggregate functions. Suppose you can see we have transaction T1 and T3. So in T3, transaction T3 is finding the sum of some data items. So it is doing initializing sum to 0. Then it is reading A, adding A to sum. And then it is going like this. Now at this point, transaction T2 starts executing. So here now again X, let's say the value was 100. So it has read 100. It has made a value of X to be 95. And then it has also written it back. But now if you look at this, it has come back here to transaction T3. Now it is reading the value of X. Okay. So what value should it read? It will get the updated value only 95. So it adds that to sum. So the value of X which has been added to the sum is 95 instead of 100. So in such a case, if say for later on transaction T1 has to be rolled back, okay, then 95 will, the value that should be read by this aggregation should have been 100. Okay, or for that matter, if these instructions did not come here, they appeared somewhere here before before these instructions were executed, in that case, the value of X would have been 100. Okay, so the aggregate will be different. The total sum would be different depending on when the item X has been added to the sum. If it was added before, its value would have been 100. And if since it is written after, it is done after T1 has executed this section, its value becomes 95. So this is the incorrect summary problem. And finally, we have something called the unrepeatable read problem. So in the unrepeatable read, it says that a transaction T reads the same data item twice, and the item is changed by another transaction T dash between the two reads. So 2 times the transaction is reading a value, but both times it is getting different values. So let's see here. I have 2 transactions, T1 and T2. So here this is doing a read X. So X was 100. Okay, it reads X as 100. It is not doing any modification to X. Okay, then in between T2 occurs. So T2 has done what? T2 reads the value 100, increases it by 10, so 110, and then writes this. So writes it back here. So it becomes 110. Now next time T1 reads the value of X, it will read the value as 110 instead of 100. So this problem is known as a unrepeatable read. In both reads, the value read is different. So these are some of the problems that occurs if concurrency control is not there. If there is no control, if you just allow any instructions, any transactions to execute instructions in any order, then these problems will occur. So because they are occurring concurrently, okay, at the same time. So to avoid these problems, what we need is something known as concurrency control. And in the next video, we shall see how concurrency control is achieved in a DBMS.